We now want to continue our discussion of section 6.4, looking at graphs of trigonometric functions. In our previous presentation, we have learned how to graph all of the 6 basic trig functions. For example, we learned how to graph y is equal to sine x. And we learned how to graph y is equal to cosine x, and all 6 of the functions in that same manner. However, in reality, as we're looking at this section and learning how to graph these functions, very often we're going to see some variation on this function that we know how to graph. For example, we might be asked to graph y is equal to sine of 2 pi x. And so we can use what we know about this graph to help us draw a graph for this one. And that's what we're going to look at in this section with a few examples. So before we get started, we need to talk just a second about the period of a graph. Now, we've already mentioned the period of a graph, and we know that for the sine function, for example, we know that the graph runs from 0 to pi over 2, and it completes a complete cycle in between those two values. If you remember, our sine graph looks like this. And when it reaches 2 pi, it starts another up cycle as a repeat of the first one. And so we say that the period is equal to 2 pi. Now, this is going to be the graph, remember, for this function. So what we want to do is we want to look at what happens when we change the x to a 2 pi x. Okay, so let's talk first about the period. Okay, so our textbook tells us that we know that the sine and the cosine and also their reciprocals go through one complete cycle over an interval of length 2 pi. So that's what we just looked at. We know that the graph completes a cycle within a distance of 2 pi. Now, it goes on to say that if the functions are changed so that instead of having an x, you have a number in front of that x, and they're going to call that number b, then the period changes as well to 2 pi divided by b. All right, so we want to keep that in mind. Our first example is going to be the one that we just mentioned, the y is equal to sine 2 pi x. And so if this is our example, the b value, the number that sits in front of the x, is being played by this 2 pi right here. And so if I want to look at what's happening to my period, I'm going to take this formula, this 2 pi over b, and I'm going to plug in my b value. So it just so happens that in this case, the b is also 2 pi. And so what that means is that this is my new period. So my period is no longer 2 pi because I've changed the function, and the period is now equal to 1, which means that if I sketch the graph of the sine function, and it has a period of 1, I ought to see the entire graph showing up in between 0 and 1. And so that's going to basically cause this graph to really compress, and we're going to be seeing something like that. Now I'm going to go ahead and show you what the book does as the graph, but that's the idea. The idea is that the period is going to change, and so instead of having this graph stretched out from 0 to 2 pi, it's going to be compressed in between 0 and 1. All right, so you can see that that is happening in the solution to part A. All right, this is the same function that we just looked at on the previous screen. They really should have a set of parentheses around this. All right, and this is the graph that produces. And again, if we look at this graph in between 0 and 1, we should see an entire sine graph shown. Nothing else changes. The highest point is still 1, the lowest point is -1. The only change is that the period has been compressed. Okay, so let's look at our second problem. G of x is equal to sine x minus pi. Now, you want to remember that maybe from an algebra class that when you have a function and this x in the function is replaced, so in other words, that x is erased and it's replaced by x minus a number, the effect that that has on the graph is it causes it to shift to the right by whatever your number is. So this graph that they're giving me, this equation, sine x minus pi, this minus pi should cause the graph to shift to the right pi units. Okay, so again, we're going to take a look at their graph and we're going to make sure that that happens. But before we do, let's give thought to what that graph is going to look like. Now, nothing else is going to change in this one. The period is not going to change because we don't have a number sitting in front of the x. So our graph is going to start with this normal pi graph, this normal sine graph that we're used to, and then the entire graph is going to move to the right by pi. So it's almost like if we could pick up this graph and redraw it, we would have our up parabola coming in here. That's this one shifted over, and then our down one's going to continue in that direction. All right, so again, let's take a look at the graph that the book draws just so that we can see things a little clearer. All right, and here is that parabola that we just drew that used to be sitting at 0 that has now moved over. All right, and so you can see that the entire graph has simply shifted over by pi units. Okay, so let's look at one other example here. We want to sketch the graph of g of x is equal to 1 plus sine of x minus pi over 4. Now, let's think about what is happening on this graph, and we're kind of comparing it back to our original sine function graph and looking for changes. So remember, we're comparing it back to the graph of sine x. And so we can see that we definitely have an x minus a number, which is going to cause that graph to shift to the right again, just like we saw in our previous example, that this is going to shift to the right pi over 4 units. Okay, so we can do that. We did that in the previous example, so we can do that here as well. All right, what other changes do we have? We have this plus 1, which looks a little bit displaced. Normally we see that on the other side of our function, but it really is just a 1 added to the function. And if you add a 1 to a function, then that's going to cause the graph, because you're adding, it's going to cause the graph to shift up 1 unit. And we have no other changes. The period does not change because there's no number in front of the x. Okay, and so the only changes that we have are the two that we've noted. We've got a shift to the right and we've got a shift up. So again, you can take that basic sine graph, which looks like this, and you can move it to the right by pi over 4 and then move the entire graph up 1 unit. All right, so let's look at that. Let's kind of look at what happens to some of these points. And I'm going to go ahead and flip to the answer so that we can see what it looks like. All right, so here is our sine graph, and it has been shifted over by pi over 4. All right, and the entire graph has shifted up by 1. All right, so I am going to, just so we're sure that we see this, I'm going to go ahead and draw the original, and let's make sure that this makes sense. All right, so I'm going to just label these points that we normally would see. Okay, so let's take a look at what's happened. All right, so let's take our point 0, 0. All right, and we said that that point needs to shift to the right by pi over 4, and it needs to move up 1. Okay, so if it goes to the right by pi over 4, it's going to come in right about here, and it's going to move up 1. It's going to be up here at the top. All right, and so that should be this point right here. All right, this is the point that's moved to the right, and it's shifted up by 1. Okay, and now we can see that kind of as a starting point, here is our original graph. And so you can see now that we have that shift to the right by pi over 4 and up by 1. And you could certainly do it with several other points to convince yourself that that's what's happening to the graph.